Hi, and welcome to the review for the Rational Expressions test. So today I am going to do all of these questions for you since I am not going to be available to help you in class. Perform the indicated operations and express in simplest form. Well, the first problem is 5a over a plus b times 2a plus 2b over 15a squared. The first thing I need to do is factor anything that can be factored. And here I have a GCF of 2. So I'm going to factor out an a plus b. Since it's a multiplication problem, I have nothing else that I have to do other than to start canceling things. So this a plus 1 goes with that a plus 1. The 5a becomes a 1, and the 15a squared becomes 3a. And that's all I can cancel. So on the top, I'm left with a 2, and on the bottom, a 3a. Now remember, you're multiplying, so those 1s don't really mean anything when we multiply. Same idea for number 2. Factor where you can. Here I have a GCF of a 3, so I need to take that out and have x minus 1. Here I can factor, and that's an x minus 1 and another x minus 1. And that's it. So I'm going to cancel out one of these x minus 1s with that x minus 1, this x minus 1 with this x minus 1, this 3 here with this 3 here, and it looks like all I'm left with is just an x on the bottom, so it's just 1 over x. Now, you can get that answer for this problem by doing a wrong method and never factoring. If you do that on the test, you will not get full credit for it. Actually, get no credit. All right, moving along to number 3. This is a division problem. So when I rewrite it, I have to make sure I stay change flip. So stay, my first fraction stays that it is, and then I change division to multiplication, and then I flip, and I'm going to flip and factor at the same time. So this is going to be c plus 2 and c plus 1 all over 12c squared. So my c plus 2's cancel out. My c squared becomes a c, and it cancels with that. 8 and 12 both have a 4 in common. 4 goes into 8 2 times. 4 goes into 12 3 times. So I'm left with 2 parentheses c plus 1 all over 3c. For number 4, same type of problem. So I will have 1 over a plus 3, a minus 3, because that's the difference of two perfect squares, times, I'm going to flip, move my 3 down to the bottom, 4a plus 12 factors to 4 times a plus 3. So the a plus 3's cancel out, and I'm left with a 4 on the numerator and a 3, and then a minus 3. Okay, moving on. Number 5, I am doing adding and subtracting, so I have to find an LCD to make a common denominator. Well, before I can do that, I have to factor my denominators. That's 2 and x plus 1, and this one's 3 and x plus 1. They both have an x plus 1 in common, and the LCD between 2 and 3 is 6. So 6 times x plus 1. This first fraction here is missing a 3. So I multiply the numerator by 3. This fraction here is missing the 2, so I have to multiply the numerator by the 2. So, you start over here, rewrite this. My denominator is going to be 6 times x plus 1. And here I will have a 3x plus 5. There's a minus sign there. It's kind of hiding right now, but it's minus 2 times x plus 4. Now, some of you want to distribute when you first write your fraction over, and that's fine. The reason I didn't is so that you can see that negative that needs to be distributed. So I will have 9x plus 15 minus 2x minus 8 all over 6 times x plus 1. So now I can combine like terms. So I have a 9 and a 2 So 9x minus 2x is 7x. And then I have a 15 and a negative 8, and that will give me plus 7 over 6 times x plus 1. And if you notice in the numerator, they have a GCF of 7, so then it's x plus 1 over 6, x plus 1. So my x plus 1's cancel out, so I'm left with 7 over 6. Number 6 is the same type of problem, except this time I am adding, and I need to find an LCD. And before I can do that, I have to factor this. This is x plus 1, x minus 1. So my LCD is x plus 1, x minus 1. The second fraction is missing just an x minus 1. The first fraction is missing nothing, so I don't have to do anything there with that one. So it will be over x plus 1, x minus 1 for x plus 6, and that's a positive one, so I don't really have to worry about anything. That will give me x minus 1. So when I combine like terms, a 4x and an x will give me 5x, and then a 6 minus 1 will give me a positive 5 over x plus 1, x minus 1. So there's a GCF of 5 in the numerator, so it's 5x plus 1 over x plus 1, x minus 1. Here, the x plus 1's cancel out, so I'm left with 5 over x minus 1. All right, moving right along. All right, number 7 is still the same type of problem. That is a subtraction problem. I need an LCD. And I need to factor first, so this is y plus 5 and y minus 5. So the first, my LCD is going to be y plus 5, y minus 5. And my second fraction here is just missing the y minus 5. Alright, so I need to multiply the top by y minus 5. So I'll have 4y and then minus 5 times y minus 5 all over y plus 5, y minus 5. It's very tempting to just cross out those y minus 5's, but you have to distribute first. So it's 4y minus 5y plus 25 all over y plus 5, y minus 5. So I'm going to combine like terms, because those two are like terms, and I will get negative y plus 25 over y plus 5, y minus 5. And that is my final answer. There's nothing more I can do with that one. For number 12, last adding and subtracting, I have to find an LCD. This is 12a, except the smallest value that goes into all of them. Multiply the first fraction by 3, the last fraction by 4, and the middle fraction by nothing, because it already has the LCD. So I will end up with 9 over 12a plus 1 over 12a plus 4 over 12a. So it's really 9 plus 1 plus 4. Oh, my bad. That's a minus sign there. And that's a minus sign over 12a. So 9 plus 1 is 10 minus 4 is 6 over 12a. And that reduces 1 and a 2. So it's 1 over 2a. All right, now we're on to solving. We're going to solve and check each equation for extraneous roots. Formal checks are not necessary. So that means just do a mental check. Make sure that you don't have to reject an answer. So here we have to find LCDs again, but this time the role of the LCD is to get rid of the denominator instead of find and make common denominators. So my LCD for my first fraction is 3x. So here we multiply everything by 3x. In the first fraction, the x's cancel out, so I'm left with 3. Plus, in the second fraction, the 3's cancel out, I'm left with x. Equals, in the third fraction, the x's cancel out, and 5 times 3 is 15. So subtract 3 from both sides, x equals 12. I'm looking to see, will 12 make one of those denominators 0? And the answer is no. Therefore, I'm done. For number 10, my LCD is y, hang on, y times y plus 2. So in this first fraction, we need to multiply by y times y plus 2. That little 1 also needs to be multiplied by y times y plus 2. And the last one needs to be multiplied by y times y plus 2. So in the first fraction, the y plus 2's go, so I have 4y. Equals, nothing cancels out there, so it's y times y plus 2. And in the last fraction, everything cancels, so it's just minus 8. So 4y equals y squared plus 2y minus 8. I'm going to subtract the 4y. So 0 equals y squared minus 2y minus 8. Now, I'm going to factor that, and I'll get y minus 4 and y plus 2. So that means y will be equal to 4. Y will be equal to 4, and y will be equal to negative 2. 4 will not make any of my denominators 0, but negative 2 will. So I need to reject that and just keep the 4. All right, last equation. All right, my LCD is x times x plus 2. Here, I need to multiply by x times x plus 2. Here, I need to multiply by x times x plus 2. Here, I need to multiply by x times x plus 2. First fractions, the x plus 2 goes, so I'm left with x squared equals. Second fraction, the x goes, and I have 3 times x plus 2. In the third fraction, everything goes, so it's just plus 4. So I have x squared equals 3x plus 6 plus 4. So I have x squared equals 3x plus 10. Now I need to get this equal to 0. So I'm going to subtract 3x and subtract 10 from both sides. So I have x squared minus 3x minus 10 equals 0. So that is factorable. So it's x minus 5 and x plus 2. So x equals 5 and x equals negative 2. And again, the negative 2 will give me 0, so I need to reject and just keep the 5. All right, we're getting there. Number 12. Simplify each complex fraction. Again, I'm going to find an LCD. And I use LCDs to eliminate the fraction over the fraction. So I use them just like we do when I'm solving equations. In this problem, the LCD is x squared. So I need to multiply the first term by x squared, second term by x squared, third term by x squared, fourth term by x squared. So nothing cancels out with the first term, so I have x cubed. In the second term, this x squared cancels, or x cancels by x squared, and I get an x, so minus x. over. Nothing to cancel the first one, so it's x squared. Here the x squareds go, so it's minus 1. So I need to do a little factoring here. In my numerator, I have a GCF of x, and I have x squared minus 1. And by looking at that, I see it matches my denominator. So even though that's factorable, I don't need to factor it again. I'm just going to cancel them out, and I'm left with x for my final answer. For 13, my LCD is AB squared. So here the A and the B cancel out, and I'm just left with the B. So I have 3B. Here the B squareds go, so I'm just left with an A. And I'm done. Some of you, looking at that one, my guess, like to do a state change flip, which is okay as well. The B cancels, that B becomes a B, so it's 3B over A. So either or is fine with me. Okay, for 14. My LCD is 50. So multiply everything by 50. So that becomes a 5, so it is 5B, that becomes a 25, plus 25 over, that becomes a 2 and a 1, 2B squared minus 50, because nothing cancels. So I can take out a GCF, so it's 5 times B plus 5 over, I have a GCF of 2, so then I'll have B squared minus 25, which is a difference of two perfect squares, so it's 5 times B plus 5 over 2 times B plus 5, B minus 5. So the B plus 5's go, so we're left with 5 over 2B, and it is 5. Last one of these, at least. My LCD is y squared. So everything's got to be multiplied by y squared. So nothing cancels out with the first one. So I have y squared. Here, y squareds cancel out with a y, and it becomes a y, so plus y. Here the y squareds go, so it's minus 6. All over, the y squared is nothing to cancel with. This y squared becomes a y, so it's plus 11y. And here the y squareds go, so it's plus 24. This is factorable, so it's x plus 3, x minus 2. And in this denominator, x plus 8, x, y plus 8, and y plus 3. My y plus 3's cancel out, and so I'm just left with y minus 2 over y plus 8. All right. Last problem. A coin purse contains a mixture of 32 coins and dimes and quarters. The coins have a total value of $5 or 500 cents. Determine the number of dimes and the number of quarters in the purse. Only an algebraic solution will be accepted. Well, let x equal the number of dimes. And we're going to look at 32 minus x equal the number of quarters. Let's see, let me extend my page a little bit so I'm on the right. So then I make my chart. I will have dimes, and I will have quarters. And this is their value. This is the number. And this is their total amount. So dimes are valued at 0.1. Quarters are valued at 0.25. For x times and 32 minus x quarters. So this is 0.1x, and this is 0.25 times 32 minus x. All right, so there's my setup all done. Now I need to write an equation. I'm trying to find a total value, which means I need to add them. So I have 0.1x plus 0.25 times 32 minus x is equal to the $5. So it's just 5. It makes you feel better, put 0.00. So I have 0.1x plus, when I distribute that 0.25, I will get 8, and then minus 0.25x equals 5. 0.1 and minus 0.25. Think of this as a 10 and a 25, negative 25, so it'd be negative 15. So it's negative 0.15x plus 8 equals 5. Subtract 8. So negative 0.15x equals negative 3. Divide by 0.15, negative 0.15. So x equals 20. And to kind of answer my question, the number of dimes is 20, and quarters would be 32 minus the 20, which is 12. So 20 and 12. Oh, I see I made a little mistake on the answer sheet. I said it was 32 minus 20 equals 32, and it should be 12. My mistake. I apologize. All right. And that is it. Good luck on your test.